All right. So in Unit 6, we're going to move into solving quadratics. So in Unit 5, we were graphing that U-shaped quadratic. We were writing that equation. Now we're going to look at how do we actually find the solutions for x. But I kind of thought we would do like a factoring review before we jumped into solving by factoring. So this is 6.1, but really I feel like it should be more like 6.05. And really, Chapter 6 will start with solving by factoring. But we're going to review factoring. So the first factoring that we're going to look at is factoring by greatest common factor, or GCF, as it's often abbreviated. So I've given you an example. We are factoring 35x to the third power minus 14x squared. So essentially, factoring is the opposite of multiplying, or the distributive property. We're going to be doing it in reverse. So essentially, we're going to be dividing. So when you're factoring by GCF, the first thing you want to do is look for the greatest coefficient and the greatest exponent in common between all of the terms. In this case, it's just two terms. So the coefficient on these terms are 35 and 14. So you want to find what is the greatest number that both 35 and 14 are divisible by? 7. Then you are looking at your variables that are attached to those, and our powers. We have x to the third power and x squared. So you want to take out or find what's the greatest exponent that both terms have in this case. And that would be x squared. So 7x squared is going to be the greatest common factor of this little binomial that I gave you. Now that you have found the greatest common factor, step 2 is to divide each of these terms by that GCF. And when we divide, we're going to put the remainder inside of the parentheses, because the factored form of this expression will be the product of this GCF and the remaining terms. So 7x squared was multiplied by what to get back to 35x to the third minus that 14x squared? Yes, so 35 divided by 7 would give me 5. And then when we're dividing powers, remember, essentially we're just subtracting the exponents. So 3 minus 2 is how you just get the x to the first power, but we don't need that 1. And then negative 14 divided by 7 is negative 2. And the x squared divided by the x squared would cancel out. So this is your factored form of this expression. I need you to come back at the end of the day. Thank you. All right, so we've got one more. Same thing. We are factoring 4x to the fourth power minus 20x to the third power. So again, the first thing you're going to do is find what is the greatest common factor. 4 and 20 are both divisible by the largest number they're both divisible by is 4, right? Because yes, they're divisible by 2, but we want to find what's the largest number that they're divisible by. Then you're looking at the largest exponent that both terms have, and the largest exponent that they have is x to the third power. So 4x to the third power would be the GCF. So now that we have found that, we will divide by this 4x to the third power, and the remainders will go inside of these parentheses. Because again, you're thinking 4x to the third power was multiplied by what to get back to this little binomial? So 4 divided by 4 would just be 1, and I don't need to put that 1 there. And then x to the fourth divided by x to the third power, well, 4 minus 1 leaves me with x to the first. And again, I don't need to put an exponent of 1. Negative 20 divided by 4 would be negative 5. And then the x to the third power divided by x to the third, those would cancel out. So this 4x to the third power times the x minus 5 would be the final factored form of this polynomial. All right, so that is your factoring by GCF review. Now, let's move into factoring these trinomials when a equals 1. So these will all be quadratic trinomials. They'll be written in this standard form. So remember, this form is ax squared plus the bx plus c. But a is 1. So I don't need, the leading coefficient is 1, so that's why there is nothing there. Remember from your past math classes that when you are factoring these trinomials with a leading coefficient of 1, they're going to factor down into these two binomial terms where the first term in each of them is just going to be x to the first power. Because if we're using that FOIL method, x times x is how we get back to the x squared. So when a equals 1, factoring should be pretty quick. But if we don't remember what it is, here is your little list of what you can do. The first thing you want to do is make a chart listing all the factors of c. So in the example that we're given, x squared plus 5x minus 24, our c value is negative 24. So this is why we did that little activity on Friday. So if you're listing the factors of negative 24, that could be like negative 24 and 1, or negative 1 times 24, or negative 12 and 2, negative 2 and 12, negative 8 and 3, or negative 3 and 8, negative 6 and 4, or the other way around, negative 4 and 6. And after you have listed those factors, then what you want to do is find the pair that also adds to b. And in this case, our b is 5. So if you're looking at what adds to 5, well, this would be negative 23, so that's not right. Positive 23, negative 10, positive 10, negative 5. There it is. Negative 3 and 8 add to 5. So you have found the two integers that multiply to negative 28 and add to 5. And those factors are what you're going to plug in to your binomial terms. Okay? So then the factored form of this expression is just x minus 3 times x plus 8. And no, it does not matter if you have x plus 8 times x minus 3. Because again, if I were to go back and use that FOIL method, I would get right back to here. All right. Let's try two more where the factoring is nice and simple because a equals 1. So I have x squared minus 7x minus 18. So again, what you're looking for is what are the factors that are going to multiply to negative 18 but add to negative 7. Because this were factored down. Yeah, what do you know if our product is negative, what would be true about the two integers? Yes, one's negative, one's positive. Very good. So, negative 18 and 1. Feel free to stop me. It's negative 2 and 9. No, that adds to positive 7. There we go. Negative 9 and positive 2 adds to negative 7. Those are the integers that we want. So the factored form of this is just x minus 9 times x plus 2. And there you go. Just like that, you've factored it. All right, last one of the easy ones. We've got x squared minus 11x plus 30. So again, when the leading coefficient is 1, we know that it's going to factor down to just 1x times 1x, because that's the only way we can get to x squared. But what we don't know are what are our two integers that make up the rest of the binomial. So what we're doing is looking for what multiplies to 30 but adds to negative 11. So this time, they have to multiply to a positive, which means the signs have to be the same. But they have to add to a negative, which means both signs have to be negative. Negative 3 times negative 10, well, that's negative 13, so that's not right. Negative 6 times negative 5, that adds to negative 11. There you go. So the negative and the negative would multiply to the positive, but add to a negative 11. So that's it. That's your answers. X minus 6 times x minus 5. All right. The last thing we're going to review is how do we factor these quadratic trinomials when a is greater than 1? So this is going to be a little harder because, for example, if we look at the example that I gave you, 4x squared minus 12x plus 5, well, if I'm looking for these two factors that this multiplies down to, well, this could be a 4x and a 1x, or this could be a 2x and a 2x to get back to that 4x squared. We don't know what that is yet, so the process to factor requires a little more work, okay? Because now we are going to have leading coefficients inside of that first term as well. So what we are going to do is use this little AC method that I know you guys have done in your past classes, and we're going to end up basically factoring by grouping. So what we're going to do is we're going to make a table similar to before, except now we're looking for a combination of numbers that multiply to a times c. So 4 times 5 in this case, which would be 20. But they still add to this middle term. So it still needs to add to negative 12. So this is a lot like the last one too, where it has to multiply to a positive but add to a negative, which tells me that both of the numbers have to be negative. So like negative 20 and negative 1, but that's not right. Negative 10 and negative 2. Very good. That's going to add to negative 12. So this time, what we are going to do with this combination of numbers is rewrite our middle term so that we've now turned our trinomial into a polynomial that has 4 terms. So we're going to rewrite that negative 12x as the negative 10x minus 2x. But then we still have the plus 5, and we still have this 4x squared. So if you think about in the last section where when we were using the FOIL method and these terms in the middle were always like terms that we had to combine, well, we're doing that now in reverse. These were the like terms that we combined to get negative 12. Now we're trying to figure out what were these two terms that added to negative 12. And it was this, negative 10x and negative 2x. Now that we have 4 terms, we're going to split the polynomial in half and find the greatest common factor of each set of binomials. So I'm going to take these two terms, and I'm going to take these two terms, and I'm going to find the GCF of each pair. So the greatest common factor between 4x squared minus 10x, so now this is back to kind of what we did at the beginning. So first look at the 4 and 10. The greatest common factor between 4 and 10 is 2. And then, yes, they both have at least x to the first power. So the GCF of the first 2 terms of this pair is 2x. If I factor that out, what is my remainder? 2x minus 5. Very good. If I look at my second pair, the greatest common factor between a negative 2 and 5, there is nothing, right? So we have to use 1. And because this first term is negative, we're not just going to factor out a positive 1, we're going to factor out a negative 1. And when we divide both of those terms by negative 1, what we're left with, a negative divided by a negative would make this a positive 2x. And a positive 5 divided by a negative 1 would make it a negative 5. What do you notice about these remainders? They're the same. And that should be true every single time. If you factor out the GCF from each half and your remainder is not the same, you know you've done something wrong. So this matching remainder is one of your final binomial terms. So 2x minus 5 is one of your binomials. And your other binomial comes from these GCFs. So 2x minus 1. And that is the factored form of the 4x squared minus 12x plus 5. Is it all coming back to you? Because if the first term is negative, you have to factor out a -1. If you don't factor out a -1, then these don't match. If you only factor out a +1, well, now you have a -2x plus 5, which is not the same. Your remainders have to match when you factor out your GCF. All right, so we have two more. We got 3x squared minus 11x minus 4. So again, because this leading coefficient is greater than 1, we're going to use this AC method where we multiply them to figure out what combination of numbers did they use to get this -11x in the middle. So we're looking for integers that multiply to the 3 times -4, which is -12, but they have to add to that middle term, which is -11. So remember, if they have to multiply to a negative, that means the signs have to be opposites. Very good. So what's going to multiply to -12 but add to -11? -12 and 1. Very good. That would add to -11. So we're going to use those two terms to rewrite the -11x. So we're going to rewrite that as -12x plus 1x. Bring down the -4. Bring down the 3x squared. Now you have 4 terms. So now we can split them in half. The first 2 and the second 2. Find the GCFs of both. And cross our fingers that the remainders match, because that means then you did it correctly. So the GCF between 3x squared and -12x is 3x. So if you divide 3x out of those two terms, 3x squared divided by 3x, so 3 divided by 3 is 1, and then the x squared divided by x leaves you with just x. And then -12 divided by 3 leaves you with -4. So x minus 4, and then what do you notice about this? It's already x minus 4, which means, yes, the GCF of that one is just the 1, right? You got to have that second term, but then it's just this x minus 4. So the x minus 4 is one binomial, and your other binomial is made up of those GCFs. So 3x plus 1 times x minus 4. There you go. You just factored that trinomial. Okay, last one, and then you guys can start your practice. So you've got 12x squared plus 5x minus 2. Again, the leading coefficient is greater than 1. We're going to use that AC method to figure out what combinations we need to use to rewrite this middle term. So 12 times -2, they need to multiply to -24, but add to 5. -12 and 2, no. +8 and -3. Very good. So plus 8x minus 3x minus 2. Bring down the 12x squared. So we've rewritten that middle term. Now that we have 4 terms, we can take these two and take these two. Find the GCF of both. So the greatest common factor between 12x and 8x is going to be 4x. And when I divide by 4x, I get 12 divided by 4 would be 3. X squared divided by x is just x. 8x divided by 4x would be just plus 2. This back half of my quadratic looks pretty similar except it's opposites, which means I just factor out a -1, right? So that I get 3x plus 2. So then now my final factors are these GCFs, 4x minus 1, and then those matching remainders, 3x plus 2. And that is how we factor when a is greater than 1.